Yeah, so I saw a to-do item while I was creating the issues regarding the data container, and the data container will be part of the LNPBP core library, or it will be part of RGB core.
It's RGB core library. It's RGB specific thing.
Okay, so so we will not be needing the data container for the current implementations of the RGB20 assets, right? Only for the NFTs, or maybe like we need to start implementing that also.
We need to start implementing that also because right now RGB20 schema uses very strange format for storing proofs of the burned assets in the future. And we need actually to migrate that for data container-based format. And also data containers will be needed for consignments when you do the transfer, because today it's really very inconvenient when you copy the string, and after few passes, you will need to copy kilobytes of back32 encoded consignment, which wouldn't work. It's really hard to transfer them. So we will need to have, and that will be implemented by Bifrost, but Bifrost will be operating using the data container. So it all comes together. So basically it has to be finalized in this iteration.
Okay, understood. Yeah.
Other questions regarding Bifrost and data containers before we move to the final part? Okay, let's discuss then the final part, which is virtualization of RGB validation rules. It's quite an important topic. I will explain what it means. So with RGB client-side validation, we have two types of the validation procedures. First of all, before distinguishing these types, I have to say that the RGB client-side validation applies to such structures as a consignments, and in some restricted form to disclosures. It doesn't apply to stash data. Stash is validated whenever you merge a consignment into it. Basically, because you validate the consignment before merging the state state is consistent. So we do not validate the stash, which is a large size storage. And the second is we are not applying the client-side validation to data containers as well. So they are client-side validated. So regarding consignments and disclosures, we have two types of client-side validation. The first one is what I call conservative. So it's based on the rules. And the important part of this validation, it's once written, never changed. Basically, it's hard-coded into RGB core library. We don't need any form of virtual machine for doing it. And it applies, it's not schema specific. It's above the schema level. It's part of the core library. And the conservative part of the validation includes such procedures as validation of the internal graph consistency inside the state transitions, that everything is referenced inside the consignment is present within the consignment, so it has a full data. It's a simple form of validation. Validation against schema structure. So we are taking the schema and validate that the contract history matches the schema rules. And it's not schema specific because it's encoded like schema is already. It can be validated across any existing or any future schema, because schema has a certain format, and we just check that it matches the contract history matches the format defined by the schema. And the final validation, which is a part of conservative rule-based validation, is validation against single-use seal commitments present inside the Bitcoin transaction graph, either as a part of blockchain or as a part of state channel. And this form prevents double spending. So it's already written. It will never change, aside from if there are some bugs and security issues are discovered. And well, it's a part of the core library, so it's there, and hopefully we will never introduce changes before the next generation of RGB protocol. So we don't need virtual machine here. There is no need for it. However, there is a different part of the validation which I call variative or script-based, and it will be specific to each schema. So each schema can define a validation rules on top of these conservative validation rules. And these validation rules should be implemented as a part of the schema. And the plan was that we will be using simplicity and related and virtual machine able to proceed the simplicity bytecode to do this validation. Before the simplicity is released, we currently just hard-coded it the same way we hard-coded the rules for conservative validation, and we hard-coded it only for RGB20 inflation. Basically, whenever we make sure that with the RGB20 schema, the amount of asset in the transition outputs equals the amount of asset in the transition inputs, we do that with this script-based validation. So we check the Pedersen commitments, we check the bulletproofs. It's hard-coded today, but in the future, it was a clear intent to make that validated by a simplicity script. So that's because this form of validation is specific to RGB contract. You may have a deflationary assets or assets which doesn't operate the content, the amount like NFT assets. And each schema will have its own validation rules, which will have to be implemented with the certain forms of scripts. And today, when we are doing a secondary issues of the and burn and replacement procedures of RGB20 assets and also work on the implementation of NFT assets, again, the question arises how to implement the schema-specific part of the validation procedures. Sorry, just give me 1 second. Sorry, I'm back. So the question is how to proceed. Do the hard coding again or finally use some form of virtual machine? Why the virtualization is actually desired as the end result? Because first of all, it distinguishes schema-specific code from other code, and it helps auditability of the code and the overall security model. It also helps isolating state of the contract from other logic of RGB core library. And the most important, it may allow creation of custom schemata, but by external developers, but by independent developers from the LNPBP Standards Association. Because before we have a proper virtual machine implemented, the only party who can develop the development of any new schema will require PRs and commitments into RGB core library, which is not appropriate. So we need virtualization. And we had a feeling that we will get simplicity before release of the RGB. And we had that feeling like at the end of 2019, we thought that it will be coming during 2020. And there were even rough estimations that by the end of the 2020 or at the first quarter of 2021, Blockstream will get simplicity running on Elements project and with a liquid network. Unfortunately, that hasn't happened. And my analysis of the development, mostly for 3 months, simplicity hasn't been developed at all. We just got first commits coming to it again just last week. And from the speed of the development, it seems clear that during this year, simplicity wouldn't get into any form of the production ready thing. So we have to take a decision right now. And which decision options do we have? Basically four options. We can leave it as is, which I called a status quo, basically hard coding the custom schema-specific validation logic into the RGB core library, which is quite a bad practice from different perspectives, for all new validation procedures that we are implementing. The second option is we can create a custom virtual machine using the same Rust code, which we are using as a hard coded. We will just separate the state, separate that into a separate library, define a state that is shared between the core library and this validation part of the logic. So I got second option, Rust-based custom virtual machine, which like a temporary solution until we will get to, so the first and the second are temporary solutions. The non-temporary solutions are using Wasm virtual web assembly virtual machine to run the smart contracts and to use simplicity to run the smart contracts. So I and basically wait for simplicity to run the smart contracts. I defined a number of parameters by which these alternatives can be analyzed, and I will run through all of them. Here with the red color, I marked the worst option, so meaning that which of these alternatives has the worst performance under this criteria. Green color marks the best performance and best result. The cyan color, actually, it's the second best because it's very important in decision making, the second best option. And the white is all the other. Because we have 4 options, it's just the second worst option. So, first of all, the code auditability, which is very important for auditing before the release. And I would have to say that the status quo as we have today has the poorest code auditability. It's basically part of the core library with a lot of other stuff. And simplicity has the best auditability because it can be formally proved. So you don't need humans to validate the code. You run the equation and basically you prove mathematically the validity of the procedure against certain assumptions. And that was one of the main reasons why we were looking into simplicity. The second parameter is safety. And again, simplicity is the safest of all options. While with the status quo, I would just have to say that I still don't have a guarantees that the same validation will work on platforms, hardware platforms with different NDNs, which has to be checked, and we need to make sure that the validation works exactly the same way, no matter which NDNs are you using. If I'm right, IRM has different NDNs from Intel architecture, meaning that because it validates on mobile today, we may assume that it works well and properly, but again, that has to be double checked. The third thing is the implementation of cryptographic primitives, specifically zero knowledge related parts, which is bulletproofs and Peterson commitments. Unfortunately, the status quo of the situation is that we are using green-based implementation of these two. The only reason why we are using green-based because there is no other implementation of bulletproofs available and in the world, so not a lot of choice. But the second, we are planning to migrate, which will be incompatible migration procedure. But also additional to incompatible migration, when there will be, we can migrate into 2 things. The first one, we can migrate into libs 256K1 ZKP version, which is maintained by LMS project and Blockstream. Today, it doesn't have bulletproofs, but Andrew Pelster has already made 2 attempts of implementing it, and he failed with the previous one. He made a new one, but it's been in review for half a year, and it's really hard to tell how long it will take to get merged. So probably again we wouldn't be able to wait for it with the RGB release. That's the first migration option. The second migration option is to wait for simplicity, and simplicity will have its own implementation of bulletproofs one day. Potentially it can take 5 years from now. So, so additionally to the actual implementation, which is green-based and no other options today, There is also migration, complexity of the migration, of the feature migration procedure. And with the status quo, we have hardest migration. While by doing a custom RISE-based virtual machine, we can smoothen that migration because we are clearly isolating the state. With Wasm, it's unfortunate because I don't have any information. Would it be possible to use bulletproofs from Wasm? And it's my major pitfall on this route. I assume that it should be possible because green implementation is pure Rust implementation, and probably we can use the same green implementation from Wasm, but not yet 100% sure. About the effort for implementing the virtual machine. Status quo is actually none. It's already implemented. With simplicity, we have extreme high complexity of implementation because simplicity by itself, it has no tool chain for developers, and it's the language of the most complexity I have ever seen operating at the level of very high mathematical abstraction. So I don't understand even how to program it. And as far as I know, there are only two people in the world who know how to program it, Andrew Belstra and the creator of the language, Russell O'Connor, both working in Blockstream. The same applies for schema validation implementation. So not the same. The same applies for simplicity because I just doubt that there may be any external schema developer who will be able to use simplicity in the next 3 years. Again, because of the absence of the tool chain and absence of the way how to learn this language and so on and so forth. With the status quo, the schema, we need to implement more validation logic both for secondary issuance and NFTs. And it's the simplest way of doing that is doing custom Rust-based virtual machine. But still the status quo is also a medium complexity of the story. And by the fact that can it be used by external schema developers to create a custom schemas not related to LNPBP association, with the status quo, it's nearly impossible. With a Rust-based custom virtual machine, it's really hard to do. With a Wasm, it's very simple to do. And with the simplicity, again, while it's theoretically possible, organizationally possible, in practice, without tool chain, without being able to have even some books about this language, it will be impossible in practice. I converted that all into scoring procedure. The conversion is very simple. So I took the red color for 0, the white for 1, the sign for 2, and the green for 3. I summed them up into 3 categories, and then I provide the overall score. And the end result is that the fact that Wasm has the high score. So it seems, first of all, we need to make sure that it will be possible to do bulletproofs and Peterson commitment validation in Wasm because it's a stopping factor. But if it will be possible, it seems that the Wasm is the way to go forward. With the simplicity, it has extremely high rate on the security, but when we come about to implementation complexity, extensibility, it's basically unusable, and it's not there yet. So it has the lowest grade, and the only thing that can be done with the simplicity is wait for another 2, 3, 5 years. I think at least 2 years, but probably 5 years, when the language will be out, when the tool chain for developers will be created by Blockstream, when there will be more people in the world who know this language and are able to program it. And at that stage, this implementation complexity and extensibility score will change, bringing simplicity to the first place. But for now, it seems that we either have to stick with the status quo or migrate onto Wasm for the first version of the RGB protocol. And it has to happen before the release. So we either migrate to Wasm and RGB goes live with ability for any developer to develop their own schemas and smart contracts with RGB, or we release RGB with hard-coded list of schema and without ability for external developers to extend it until the next generation of RGB is released in several years, which I think is a very poor way forward. That's end of show. So let's discuss this matter.
Yeah, you have made the decision making process really easy here. So yeah, it seems like Wasm is the right way to go. And I don't think the implementation complexity will be much higher also than Rust based custom VM, and other people can also like test their own variations of the smart contracts. So yeah, Wasm seems like a good option here. So
And,
I'm cool with Wasm.
and from what I understand, what we need to get to make Wasm virtual machine is basically Wasm compiles from Rust, so we don't need to rewrite the code we have today. To modularize it and make sure that it compiles with Wasm. And the most complex part of the story probably would be to get bulletproofs and Pedersen commitments being compiled into Wasm code as well.
Yeah, right.
Any other thoughts from anybody else?
Well, to me, probably the hard coding itself is conceptually a bad design decision because the whole concept of RGB is about being modular and open for everyone and free as in freedom. And by hard coding something which is not a conscious design decision, but like a no way out solution, is kind of contradicting the initial concept of the whole project. So yeah, probably the Wasm right now seems to be a good way forward. Though, yes, as you said, we need to first probably learn more about the details that we have. Very, like, not a lot of information, but then probably we would still stick to that. I mean, I'm sure that a lot of developers, even now, they're saying about, even those who are aware of how smart contracts and schema work in RGB, they're still asking if they would be able to create their own schema. So that's like our highest topics. And if we hard code something now, I'm not sure if that would be a very good decision.
Well, to be more clear, they will be able to create their own schemas even with status quo, with the only exception that they will not be able to add custom validation logic to their own schemas, which in most of the cases cannot be required. Like, for instance, we have a schema for simple schemas. For simple schema, it's not required. Like, we have schema for auditability log records, for creating audit log of the state of the events, and there we are not using any validation logic other than schema embedded into the schema, but it's simple forms of schema. If they will need to do something more advanced, like create an asset which will be deflating, they will need to use scripting, and with the status quo it wouldn't be possible.
Well, by that, we're reducing the amount of use cases that RGB can be applied to, which is probably not, I mean, I don't see the benefit that we are getting if we establish that limitation. I can see the drawbacks, but
yeah.
I see how we benefit from it.
Yeah. Well, the only reason of not doing that is that we estimate the amount of effort required for Wasm as inappropriate, but it doesn't seem so.
Raj,
well,
yeah, go ahead.
There are other options which I haven't added here, which we can use. We have at least 4 more virtual machines used in the decentralized applications today. The first virtual machine is classical Java, JVM. We can use it, which I haven't put it here because it's bad from all the perspectives. starting from that it's has certain proprietary problems with Oracle, and everybody who was using it had those problems and legal issues, coming to the fact that it's not suited for any decentralized environment in reality. So it's not isolated from the systems and so on and so forth. The second virtual machine is even worse, which is a common runtime environment by Microsoft, what is also known as a net platform. Again, even worse thing. The next virtual machine is EVM, Ethereum virtual machine, like no comments, and that's why I haven't added it here. While I wouldn't say that EVM itself is insecure, so it's a solidity language, which is a problem. EVM is a bit secure, and we have a KeyVM, which is formally validated version of EVM by IOHK company. So it's okay-ish, but I think that from even PR perspective of using Ethereum virtual machine in RGB, it's a very good decision. It's a very bad decision. And the fourth virtual machine is ELE by IOHK, used in Cardano, which is a good virtual machine. It's formally proved, formally validating. We have a programming language, which is a Haskell dialect for it, a well-developed programming language, Plutus. But again, it's used with the shitcoin Cardano, and I haven't actually considered of using it. And it's being supported and developed by a private company, IHK, which is a bad dependence decision. So Wasm seems like the only viable option to simplicity, which is again still developed by a single company, Blockstream, at least with a different level of trust and with extreme benefits coming from the formal validation of this simplicity. But again, we can't use it today. So literally Wasm seems like the only viable option.
Very good description and analysis, actually. Raj also just sent 2 links to the chat. I will post.
Yeah, I just think I found a snark implementation in Wasm. So
what implementation?
It's zero knowledge proof implementation, snarks, and I'm not sure whether it contains bulletproof or not. Probably it should.
No. The snarks is a different thing. We need bulletproofs. So it's a different zero knowledge. They're compatible.
Okay.
So we need, well, basically there will be no bulletproofs for Wasm. What we need is to make sure that green zero knowledge library, which is green SecP 256K1, compiles to Wasm. That's the only thing that we need, because there are no other bulletproof library, especially tested in the production. So we need, the only thing that we need is to make it compile for Wasm virtual machine.
Okay, yeah, sounds good.
Which I'm not sure that it may work, but I would like to have it working. Okay, any other thoughts?
I think we can wrap this up if no one has any questions.
Yeah, 1.5 hours anyway.
Yeah, that's pretty much enough. So I'll post all the information from today's discussion as a video, audio recordings, and as discussions. And I'll drop all the updates like across all the channels that we have. Let me put it like this.
Okay, thank you.
Good. So thank you very much, everyone, for coming. Maxim, thank you very much for a very, very good presentation. We have a lot to think about now. So if you have any questions, you know where to find us. Have a good day. Thank you for being here.